Review Chapter 11. This is the first half of our Chapter 11 review, 11.1 through 11.3. So let's start here with our solid figures. We're asked to find the number of vertices, edges, and faces. And so we start with vertices. I find a spot on the top, and 1, 2, 3, 4, 5, 6, work my way around. Do the same thing on the bottom, 1, 2, 3, 4, 5, 6, no surprise there. So we have 12 vertices. And then I'm going to do the same thing with the edges. I'm going to start my way around the top here, 1, 2, 3, 4, 5, 6 edges on the top. Go around the middle, 1, 2, 3, 4, and then there's 5 and 6 hidden in the back, but that's no surprise either because it's a hexagon. And then around the bottom, 1, 2, 3, 4, 5, 6, same as the top, so we have 18 edges. And then our faces, there's 1 on the top, 1 on the bottom, and then 1, 2, 3, 4, 5, 6 around the middle. Again, not a surprise because it's a hexagonal prism here. And so that makes 8 faces. That was easy enough. And if we look at our Euler's formula here, 12 plus 8 is 20, 18 plus 2 would be 20. So good to go on that. We are asked to draw and label a net. So now there's many ways to do this. One of the easiest is to just unroll the middle. We've got a bunch of rectangles there. So I'm going to unroll the middle. 1, 2, 3, 4, 5, 6 rectangles in the middle. And then I'm going to put a hexagon on the top somewhere. Let's put that over here. 3, 4, 5, 6, and 1 on the bottom. Let's put it over here. Doesn't matter where you put it. And there is our net. And now let's label these pieces. Well, I know the height here is 15 meters. And around my hexagon is going to be 4 meters on each side because we see that it's a regular hexagon, which means that all of these rectangles are 4 meters long. So we could label all the pieces, or just that many is enough. We could label around this hexagon as well if we really wanted to, but we're good to go there. All right, lesson 2, 11.2 and 11.3 were on surface area and lateral area of, well, 11.2 was on prisms and cylinders. And these also include volume, but we'll save that for our next review. That's sections 4 and 5. And so we're supposed to state our answers in terms of pi or in simplest radical form as needed and round to the nearest tenth. So let's get started here. First thing I'm going to do is find my bases. This is a rectangular prism, so it doesn't matter where the bases are, so I am going to put them on the top and the bottom. And then I am going to make a note that the height of my prism, that's this guy over here, is 6 feet. And I'm going to draw my base. And then 3 feet and 4 feet. That is going to let me find the perimeter. The perimeter is going to be 3 plus 4 plus 3 plus 4, because we know as a rectangle, these are also the same lengths. So my perimeter is going to be 14 feet. I am going to use that to find my lateral area. My lateral area is the perimeter times the height of the prism, which I've already identified. So that's 14 times 6, and that means my lateral area is going to be 84 feet squared. Next, I need to find the area of my base. And the area of my base, this is the base of my rectangle. This is the height of my rectangle. Area of a rectangle is just base times height. So that's going to be 3 times 4. The area of my base is 12 feet squared. And that is going to let me find my surface area. Surface area is of a prism is simply lateral area plus 2 times the area of the base. And so we have lateral area is 84 plus 2 times 12. So that's 24. So my surface area is going to be 108 feet squared. Okay, next figure. First thing we're going to do is identify our bases, and I see them here. My 2 parallel congruent faces are on the top and the bottom. That makes this a triangular prism. And I am going to draw my base, and my base happens to be a triangle, a right triangle no less. This side's 10, this side's 12. That means to find the perimeter, I'm going to need to do a little Pythagorean theorem. First off, I'm going to identify the height of my prism here is 9 centimeters. There's my height right there, base to base. And now let's work on that perimeter. So I'm going to do Pythagorean theorem, 10 squared plus 12 squared equals c squared. This side is c, hypotenuse is always c. 100 plus 144 equals c squared, so 244. And then I must square root both sides. So I am going to actually take the square root this time because I need to add all these up for my perimeter. So I'm going to keep several decimal points. 15.6205. So my perimeter is 10 plus 12 plus 15.6205. So my perimeter is 37.6205. That's going to let me find my lateral area. And my lateral area is simply perimeter times the height of the prism. So my perimeter is 37.6205. Height of the prism is 9. My lateral area is, put that in the calculator, 338.6, and that's centimeters squared. Now I need to find the area of the base, and my base is just a triangle, so that's 1/2 base times height. Luckily, this is a right triangle, so there's the base of my triangle, the height of my triangle. Height is always perpendicular to the base. That makes these right triangles very nice. 1/2 times 12 times 10. Area of my base is 60 centimeters squared. Means I can easily find my surface area, which is lateral area plus 2 times the area of the base. That's 338.6 plus 2 times 60. 2 times 60 is 120. So my surface area is going to be 458.6 centimeters squared. That was fun. And next problem. Salt comes in a cylindrical container. So let's draw a cylinder here. My cylindrical container and it says it has a diameter of 8 centimeters, which means my radius is 4 centimeters, and a height of my cylinder here is 13.5 centimeters. There's my height, base to base. Okay, so because cylinders are circles, they have their own set of formulas. So lateral area is 2 pi RH, which is 2 times pi times my radius is 4 times my height is 13.5. That means my lateral area is, multiply all my regular numbers, 108 pi. Put that into the calculator and we get 339.3 centimeters squared. And surface area has its own formula. Lateral area, which is 2 pi RH plus 2 times the area of the bases is pi r squared. 2 times pi times the radius times the height, 13.5, plus 2 times pi times my radius squared. We already know the lateral area is 108 pi, plus 16 times 2 is 32 pi. So my surface area is 140 pi, or if we put that into the calculator, 439.8 centimeters squared. Those were fun. All right, pyramids and cones. We do exactly the same thing, only we use our other set of formulas here. So let's look at our first problem. And we have, first off, this is going to be a square pyramid, and I'm going to identify my base here. So square pyramid. And we know that the slant height is 7 centimeters. That's this right here is the slant height. We don't know the height of the pyramid, but we could find it if we needed to. And I'm going to draw my base, even though this one's really easy. 8 and 8. And that is going to let me find the perimeter. It's a nice square here, so 8 on all sides. Perimeter is just 8 plus 8 plus 8 plus 8. We could do 8 plus 4, but I kind of like to add my perimeters. Just kind of keeps me remembering that it is the sum of all of the sides. And so that's going to let us find lateral area, which is 1/2, because these are triangles, the perimeter times the slant height, which is 1/2. My perimeter is 32. My slant height is 7. So my lateral area turns out to be 112 centimeters squared. Put that all in my calculator. Then I'm going to find the area of my base. My base is just a square, which is just base times height, which is just 8 times 8, which is 64 centimeters squared. That lets me find the surface area. The surface area is just lateral area plus 1 base on these pyramids, which means lateral area is 112 plus the area of my base is 64. So my surface area is 176 centimeters squared. That one was nice and easy. Next problem. Oh, this one doesn't look quite as easy. What do we have here? We have a hexagonal pyramid. I see a hexagon there. And what do I know about my hexagonal pyramid here? I know that it has 6 sides. The length of each side is 2 centimeters. And this right here is the height of my pyramid, 6 centimeters. And so I believe that I need to draw my base. Well, actually, I don't need to draw my base. What do we have? We have the height. What are we looking for? We are looking for the slant height here. We need the slant height. How are we going to find that slant height? Well, we need how long this is. Now, since this is not a square or a rectangle or anything like that, what is that piece? Take a look here. That's our apothem, isn't it? When we cut out our triangle. So I am going to draw the triangle for my hexagon. And we know all hexagons are this 30, 60, 90 right triangle. This is x root 3. And so I'm looking for my apothem. And how long is this x side over here? This x, this is going to be 1 centimeter. So my apothem here is going to be 1 square root 3 centimeters. So the apothem, I'll just write it here, is square root 3 centimeters long. And what's that going to do for us? That is going to let us find our slant height. This is our slant height. This is 6, the height of our prism. And this is our apothem here, square root 3. So I know, just a little Pythagorean theorem, 6 squared plus the square root of 3 squared plus, not plus, equals my slant height squared. So 36 plus, what's the square root of 3 times the square root of 3? Just 3 equals my slant height squared. So 39 equals slant height squared. I'm going to square root both of those. So my slant height is the square root of 39. And I am going to leave that in square root form just to make it easier to deal with in my calculator. This is going to let me find my perimeter. The perimeter of my base is just n times s, which is 6 times 2. My perimeter is 12 centimeters. And now the slant height lets us find lateral area. So now my lateral area is 1/2, because they're triangles, perimeter times slant height. And I have all of these pieces. So that is 1/2 times 12 times the square root of 39. And we aren't afraid of that because our calculator knows what to do. So lateral area is going to be 6 square root 39 if we wanted it in simplest radical form. And put that into our calculator and we get 37.5 centimeters squared rounded to the nearest tenth. Now we need to find the area of the base, but we have done all of the hard work already. So the area of the base is just a hexagon, which is just 1/2 times my apothem times my perimeter. And so this is just 1/2 my apothem is square root 3. My perimeter is 12. So the area of the base is just 6 square root 3, which when I put that into my calculator, 10.4 centimeters squared. And surface area is just lateral area plus 1 base. My lateral area is 6 square root 39 plus the area of my base is 6 square root 3. If I wanted to leave that in simplest radical form, that is how I would leave it. Or I can just put it through my calculator, and surface area equals 47.9 centimeters squared. So we could leave it in simplest radical form or to the nearest tenth. And on to our last problem here. This is a nice cone. What do we know about our cone? We know the radius is 4 inches. The slant height is 10 inches. Now, if we need to, we can find the height of our cone, which we will for volume, but we don't need it just yet. So that's our slant height there. So cones are nice because they have their own formulas, just like cylinders. So lateral area is just pi RL. Pi times my radius times my slant height. Lateral area equals 40 pi, or if I put that into my calculator, 125.7 inches squared. And surface area has its own formula. Pi RL, that's our lateral area, plus the area of one base, pi r squared. So pi times the radius times the slant height plus pi times the radius squared. We already know our lateral area here is 40 pi plus 4 squared, 16 pi. So my surface area would be 56 pi, or if I put that into the calculator, 175.9 inches squared. So there we go. That's 11.1 through 11.3. Make sure that you label everything. First thing you do, find your base. And then you redraw your base, label your base. Find your perimeter, identify the height of your prism, which goes from base to base, or your slant height of your pyramid, which is the height of the slanted side. And then you write your formulas and substitute in. You find lateral area, you find the area of your base, and then you find surface area. If you do this in steps, these problems will be very easy for you. So enjoy your studying.